Welcome back, everybody. I'm excited about today's show. Rad Dad in the house, John Calfan, Bobby Nealon.
What's going on?
Bobby's sad because Belichick finally retired. Well, you might be happy if he retired. I don't know.
We got Mayo. I mean, he wasn't. I mean, he wasn't turning the ship around in the next 5 years. But I mean, yeah, we'll see how it goes.
And then we've also got Alex Fortin, the CTO over at Coldbore, joining us today. Appreciate you jumping on with us, man.
Yeah, great to be here, guys.
What's the current temperature up there? Because we're currently got that cold front.
Yeah, I'm really bad with Fahrenheits. So
generally,
I got minus 37 Celsius. I know, like, it kind of converges
cold enough
around there, right? So I think it's probably minus 32 Fahrenheit, something like that. So the Mustang didn't start this morning. So got the kids at home. I was like, no, we're not doing this. You guys staying here.
That's awesome.
Yeah, it really does make you appreciate your natural gas feed out here.
Oh yeah.
Sure.
No, that's one of those things that I love about the South. Like, I wish we had actual winters and falls, but I also like the threat of snow will shut down schools here. If it does snow, we're definitely not having school. Like, if it ices, we might be out for a few days. I remember in college we had an entire week off because there was an ice storm. Like, and I just went to another college and partied all week. It was awesome. But yeah, up north, people are
it's all hard, and
you just gotta go get your shit done.
Yeah, I know. I'm going to Houston next week. I hear it's going to be around in the 20s Fahrenheit.
Yep.
And I'm sure it's going to be a bit more chaotic than here in Calgary in the minus 30s.
Assuredly.
For sure. Well, depending on how long you're here, it'll probably be 70 by the time you're gone. So
yeah,
it was 70 yesterday.
You don't like it, just I was hoping to get a little bit of warrant while I was down there.
Was it? Derek Turk was trying to get me to go speak at the SBE thing that they're doing at the end of the month, and it's in at Kananaskis, I think is how you say it. I'm not sure, but looks beautiful. Looks beautiful, but like SBE, we've talked about this. They don't pay for you to go speak at their events. You pay your way, and then B, it's like it's Calgary at the end of January. So not my idea of fun necessarily.
No, fun travel in snow is never the best, especially when you're flying and stuff. But no, I mean, I didn't go to PA from like when I was in sales. I would not go to the Marcellus from like November through February because I was like, I'm not going to I'm gonna have to rent a car.
Yeah,
and I'm gonna have to figure out if it's 4-wheel drive or all-wheel drive, like all that fun stuff, and then just the liability of it. Like, I don't drive in the snow. I know how to, generally speaking, but not nearly as good as people who do it every year. Anyway, well, thanks for jumping on. We'll get out of that rabbit hole, but tell us a little bit about your background. We met, I think, initially when I was at HiveCell and stuff, talking to you guys about some of the edge stuff. But kind of how did you get to where you're at today? Were you always kind of into the science and the technology side? Did you like tearing shit apart and working on cars? I mean, I've broken both cars and computers growing up, so I've always just loved fixing stuff. But kind of tell us how you got it.
A bit of an say unconventional track to where I'm at today. Honestly, started coming out of high school. It's kind of the kid that didn't know what you wanted to do, kind of just floating and having fun. And went to work for a little bit. And at the time, I worked on the railroad here in Canada, Canada National Railway, and then moved, and then also worked for Bell Canada out here, which is a big telecom company out east. That's really kind of when I started in technology, starting to install fiber optics and dabble in everything networking. And then was probably a little smart to be just like a tech out there full time. So they kind of had me do some fancier things. And then started to do some courses on networking and stuff like that. So we got to my Cisco CCNA, like that type of stuff. And then decided to go back to university to do my comp sci degree after that, when I was in my mid 20s. And then got hitched up with a chick, and then she wanted to move to Alberta. So I'm originally from Quebec City, and so we ended up in Cold Lake here. So that's one of that's the big Canadian Air Force base here, where you intercept those Russian bombers that comes up the polar circle. And so I was finishing my degree out there, and then that's how, and then got my first job actually in Edmonton for Coldbore back in 2016. At the time, what we were doing was sonic, uh, acoustic telemetry
Right.
for ball drops. So we were like still in completions, but on the ball drop side, right after the 2015 downturn. So it was an interesting environment.
Yeah.
Um,
Y'all were
Worked
just using
there for a
acoustic
bit.
monitoring for ball drop validation, essentially.
Yeah, exactly. Right. So we were, we're developing our own kind of hardware sensors that we're hooking up there. And then we had technicians go out there, and what we were doing at the time was trying to, it was still the early days of stuff like machine learning. So we're trying to build up a database of, what does the ball launch sounds like? What does the ball seat sounds like?
Right.
All those events so that we can confirm on top of pressure, all the operation during a ball drop. And then that was out in Edmonton, so it's kind of tired to do the back and forth between Cold Lake and Edmonton all the time. So wife found a job in Calgary. I found a job in Calgary, and then it split ways with Coldbore originally to work for a defense contractor here in Calgary. Well, it's an American defense contractor, General Dynamics, work on military telecoms, which actually is interesting parallels with some of the stuff that we see in the oil field,
Yeah.
which is like 80s style technologies that still run in the 2020s.
Right. It's just hardened 80s tech, right?
Yeah,
That's been
that's right.
refurbished and revamped over the years.
So it was working for the British military. They were revamping their stuff, but they're still running kind of their high frequency, like very high frequency radios from the 80s, and trying to send emails over it in the middle of the desert out in Afghanistan. A very interesting experience, like working there for defense. And then and then the entire crew at Coldbore moved back to they all moved to Calgary. We had our sales in Calgary before, but all our technicians and technology groups were in Leduc, just out of Edmonton. And then and then they moved to Calgary out in 2019, and they knew I'd moved to Calgary and they wanted me to come back. So that's when I rejoined Coldbore back in 2020. About 4 months into the pandemic, minus $49 a barrel WTI, and I thought that stock was a bit low. So I said, yeah, I think it's probably time, because I think there's still a lot of growth there to happen, and then join when the team was still pretty small. And then all the way to today, where we grew the company by about tenfold, I would say, roughly, since I joined back in 2020. So it's been quite the experience.
Yeah, y'all have had a ton of success, and I, as someone who was a frac engineer originally working in the field, y'all are solving all the problems that I was incredibly frustrated with, and then moving to the office. And Bobby and I, we initially met at Reservoir Data Systems, so we were doing surface and downhole gauges with telemetry, and that's where I got into the data and the comms side of things. But that was one of the things that we were also got moved into product, and so one of the new products we were working on was like frac data, streaming frac data, right? And it's like, hey, these guys are also already doing that. And
that's where we first heard about them. It was at Urtech in Colorado, was it 2019? And I think we were talking to someone at Corva, and they're like, oh, yeah, just coming to Coldbore. And it's like, oh, interesting.
Not another.
Well, and one thing too is, and it's funny too, maybe you can shed some light, is we would always like scout, and we would see these Canadian companies, and we're like, please don't let these Canadian companies come down here, because because we were doing stuff that maybe no one else in our little domain was doing, but there were a couple other companies, including you, up there, and it's like, please don't come to America.
Please don't compete with us. No, that's y'all are solving a huge problem, but can you kind of jump into just high level, what Coldbore does, what layer 0 I know is a big thing for you guys. Kind of just talk about that, so that it kind of gives the foundation for the rest of the conversation, so to speak.
Sure. Yeah. For anyone, like, to me, I try to always draw a parallel back to what Payson did in the early 2000s, right, on the drilling side, and it's really, really a good one. But the reason why completions didn't go through a similar process as fast as it happened on the drilling side is the complexity of the operation and completions, on top of the fact that you have lots of vendors, lots of service companies that are having to be joined together.
No standard to
so
the WSML for whatever it is a standard.
Yeah. So many people just don't realize that, right? Like they also don't realize that most oil companies, until they start producing the well, generate none of their own actual data, right? Like the production data is theirs. I mean, it's all their data, but they don't generate any of it until they get to that production phase, really. And so it's like, it's this data nightmare on the back end where you're the operator and you've got wireline data coming in over here. You've got pump down data, frac data, chemical data, sand data, water transfer data. You've got all of these data sources coming in. There's no standards across any of them. There's not even an agreement upon like how frequently the data should be pulled. And so that's what these guys are solving. And it's a huge benefit because, I mean, besides drilling, frac is the next, it's probably, I haven't
they're
seen
almost
AFE,
probably about equal roughly.
They're probably on par with each other as far as your costs, which are, that's probably what 95% of a well's AFE is drilling and completions. But we've had all that on the drilling side for so long, but on the completion side, it has been just a complete cluster. I remember one of the first times Bobby and I were talking to a potential customer about our new frac stuff. He had been working on a frac model, a frac machine learning model to go in and normalize the naming conventions of all their post-job data because they,
and that was just taking in the post-job like thing, not streaming it. That was getting, almost doing their own well data labs kind of thing.
On the back end, 10 years worth of stage post-job reports and stage files trying to come in and just normalize the naming conventions so that they could then go build a model to actually do something with that data, right? Like people just don't think about how complex this shit gets very quickly with all that stuff.
Yeah, it's an interesting point because most of the time, like people, when they think of Coldbore, they think of operationally how we support the company man that's out there, and that's a big part of it. But also more and more what we see with clients that are operators that are starting to get into machine learning and AI, and trying to leverage that data that they're getting. A data science project, a classic one, and that's not just an oil and gas problem. It's a everywhere problem. It's you get 80% of your time spent on what they call data wrangling, right? Where it's like, how do I put a data set together so that I can now have a clean enough set to be able to do all the fancy things that data scientists want to do, right? And the further from the source that you are, once you do that operation of wrangling, the harder and the most complicated it gets, right?
Absolutely.
And that's really a big problem that we saw for them at Coldbore, because we do this standardization and contextualization of the data on site in real time, so that there's not any guesses that needs to be made post job. Once the pad's done, like everyone's split off, they're already fracking a new set of wells, and then if you're trying to find out, kind of like, hey, like, were we fracking this well or that well at that time, or were we dual fracking? Because I see the pressure it's kind of weird there. By then, like, that information is out in the ether, and it's really hard to make sense of it.
But even like timestamp synchronization, that was one thing that we would pitch, say even at RDS, or especially when we were doing the frac van thing, is because we would have it all coming through the same, DAC or data acquisition device, data logger. Because we had our own pressure gauges, and then we would stream the frac van, they would be on the same time sync. And that was at the time where you had like reveal. And then, now you've got some of the stuff that came out of Dev and the sealed wellbore stuff where, all right, well, you've got this, pressure gauge that has its own timestamp. And then you would get the frac data, and then people would have to merge that, and they'd have to shift the data. And I mean, who knows if it was UTC or was it in the right time zone? Did they account for daylight savings? And then just, the float of computers is different. So like, there's no way to even really assuredly get that. Whereas, when it comes from a system like yours, that it's kind of all coming through the same thing. I'm assuming, the wireline data and the frac van data, and then even associated pressure gauges and all that stuff is coming through, the same computer roughly, and they're all time synchronized.
Yeah. I mean, we would have to put pressure gauges on the treatment wells, even though we were monitoring the offsets for frac hits, just so that we could normalize the frac treatment data. Or actually, it was for the client. The client would do that. So they would use the treatment data from one of the pressure gauges that we had on the treatment well, and then they would use that to line up the frac stages, and then they would layer on the offset gauges to see if there were pressure hits. But like without that gauge on the treatment well, it was pretty much impossible to figure out how you layer over those stages on top of them.
Or someone has to manually go start tagging it.
Right.
And the way we look at this synchronization is twofold. Like you're saying, the obvious one is kind of like, okay, let's synchronize all our computers in damn NTP server, so we don't have to worry about that too much. And GPS, even like everyone, we always have GPSs on site, right? It's like, it's not that hard, and that's a really good source of time. Yeah. And we make sure that we synchronize all that data for the customers, so that again, like when they come on the other side, then you can trust that if they want to correlate something that happened on, like you said, offset wells and well fracking was going on, then they don't have to think about that.
Yep.
And two, there's also the fact that at Coldbore, like really believe strongly that, you know, having the information of the frac tree and being able to correlate all of the operations on pad to what's happening on the frac tree was also like, it's kind of like it's another type of synchronization, because really kind of like you want to synchronize around, because essentially like everything that happens on site ends up at the factory, right? So you can correlate all those activities to the factory. And that's what we really kind of started making a difference is, you know, back in 2019, there were no like, you know, downing and that, or they were, you know, not as well known. And so like most of the fractures you're seeing out there was this dumb iron, and then starting to equip them with a bunch of pressure transducers and valve position sensor allowed us to create this data set that, when I talked earlier about the contextualizations, like I'm streaming you the data to the customer, but I can also give the data to the customer that already is decorated, if you will, with like, hey, you know, your valve opened at this time, so you started fracking there. You were idled for about on this well. You were idled for about 2 minutes, where the frac tree like was ready to get pressure, but I don't know what the frac guys were doing. So for 2 minutes, nothing happened. And then we see pressure up, and then, you know, start your slurry, then your pad, your flush started at this time. And so when you're trying to analyze something, like you even go from that contextualization layer to say, okay, what am I interested in? Okay, stage 57, well B, you know, plug and perf phase. I can just ask the system to get the data that's relevant to that. And that makes a big difference in the workflow for our customers.
Yeah, I believe y'all were the first ones that I ever saw that had the valve positioning sensor on it. And I thought that was just such a brilliant fucking idea, because it allows you to understand, to your point, all of the context, but also those little very important things like which well, right? Like I can't tell you how many times it would happen where we would put equipment on pressure gauges on a well, and the company man would say it was this well name, and then we would go back, and then the engineer calls us and it's like, why is the well name this? It's supposed to be on this well. Like, well, this is what the company man told us to do, so that's what we did because he's the boss, right? Like, and then so you expound that over, you know, that's the thing with frac data, right? Is it's pretty dense as far as just the volume of it, generally speaking, not like big data, but then you have so many stages, right? You're talking about thousands and thousands and thousands of stages every single year that you get. And so it's like, I mean, when I was in the field, we didn't put the well name in the DAS file, right? Like that wasn't in there. It was in the file name or in the folder that the file was stored in, right? Like, and so, well, shit, that doesn't work for a database when you're trying to do big data analysis on the back end, because you don't know what well it is. And so just like those little nuanced things are just so important with this type of data, especially on the operations side, because that's where all the money is spent, right?
When you talk about, you know, I think you were starting to hint some at like NPT, where it's like, this valve was open and 2 minutes went by while we're just idling the motors, and we weren't actually even doing anything productive. And it sounds insignificant for one, but you do that per hour, you know, 3 or 4 wells on a pad times 30 plus stages, times
crews working,
you know,
in the
across
field.
365 days. And like now you're talking hours, you know, that cost a lot of money.
Yeah. No, there's so much up
those NPTs too. Like what's great about a system like ours is that you can actually tell from the sensors, right? You can have a sensor driven like algorithm that determines who's responsible. Like in that case of the frac idle, like who's responsible from the NPT? Is it the frac company or is it the frac tree company? Because you'll see if the valve is open and the pressure, like, or vice versa. And so like normally like you would get, if you just look at the data, all you see is like, I see that nothing like I see this well switch took 2 hours.
Right.
So
but I don't know why. Right.
I don't know why. Right.
Yep.
Exactly.
Yeah. No, that's like I said, it's one of those things, unless you've messed with it and tried to do anything with it, you really don't understand how hard that problem is or was to solve out of the gate. But there's a couple things I want to talk about. I want to kind of get your kind of strategy as well as just recommendations around how y'all approach the edge side of things, because y'all are unique in that fact. A lot of people, they get data from APIs or whatever, but they're not actually all the way down at the ground level where the data, they're not only acquiring the data, but they're generating the actual data and then transforming it and then pushing it up. And so, I mean, I'm, like I said earlier, we met because I was working at an edge company. I am pretty bullish long-term on edge in the oil field and the things it's going to be able to do for us. But, you guys are actually implementing it and doing it on a day-to-day basis. So I'm very curious as to just, your thoughts on it, how, the things that you guys have done that were big wins, some of the things that you would, if you were at another service company sitting and watching you talk about it, lessons learned, things that you wouldn't do and things like that.
Yeah, sure. Yeah, it's a very good question. I mean, in terms of processing, I would say that we're not doing so much processing that because a lot of times, like when you hear the stories about the edge, is like people start to do so much processing in the cloud, it just becomes non-economical.
Right. It's not data storage.
So for us, like we're really doing the contextualization, a lot of the computation on site, not necessarily because like it's like a cost saving or a cost optimization path, but it's more like that's the service that we deliver to the client that's actually on pad, right? So by default, we have to do all our computation, because like if you look at our edge application versus our cloud application, it's actually the same thing, right? And the idea was always, and especially like, think pre-Starlink world. I know like we're all used to having low orbit satellite mounts, I guess. So, but like just 3 years ago, working in New Mexico, like how can I make sure that my client has like access to the dashboard over the internet at any given time over a cell tower out there? That was not something that we could guarantee to the customer, right? And so that's kind of how we develop our edge solution, was the fact that we're isolated with potentially no internet access or inconsistent one or low bandwidth one. And that's much more like what drove our adoption of like edge, the way that we did it, rather than what you hear, the talking heads in Silicon Valley as to like what edge is for and why it's important.
Yeah.
You know what I mean?
No, for sure. That's the funny thing is like I'm bullish on edge for oilfield because of the connectivity
issues
and remote piece
and the risk. I mean,
the risk.
You can't ultimately go blank
right.
waiting on it to get to the cloud. I mean, you can't have the cloud be that business critical piece when you're running field operations. Like they need that visibility, and they're paying for that visibility that you're providing them.
Right. Well, and even when you get, just as something as simple as, hey, the connection went down, right? Being able to have a local device that stores the data, and then when the connection comes back up, has the pub sub relationship that checks and sees, okay, well, this was the last record in the database. Here's all the records I've got. Let's go backfill that so that we can catch up and just keep things going, right? Like just the simple pieces of that are so like relevant to the oil field, because that happens all the fucking time. Right?
Yeah, it's not if things will go wrong.
Right. Like, it's when and how do you mitigate
it?
It?
And that's always kind of been our philosophy, right? It's like we need to be able to buffer that data. Like most of the stuff that we run in the field is hardwired. Like there's so much radios and things like that on pad, and all sorts of interference that, Wi-Fi even out there, like it's always kind of a crapshoot, right? So in terms of our data, like if we're going to do some wireless, we're going to be something out of classical bands and stuff like that to make sure that always by ourselves. So that's one of the lessons learned, I would say, is like, your strategy when it comes to wireless. Wireless is always good on paper. but in our experience, it's been quite challenging, both from a performance standpoint and a security standpoint. When it comes to the big lessons learned for us, if we want to get really nerdy about it, between edge and cloud is this two-way. You're running an app that basically is a duplicate of one another from edge to cloud. We've always kind of tried to be able to do two-way communication, like that you have your database sync from edge to cloud and cloud edge.
Right.
For example, like you get, let's say you get a water, like we do a lot of work with water transport company out of Marcellus. Like commodities, the Marcellus is kind of a pain, right? If you've ever been in the Appalachians, like you know why. And so like they would send us their data, from an API. So we, query their API on the cloud, and I move this in our cloud database, but then we wanted to drop that down to the edge so that if we had a customer that was relying on our edge device application, like you could also have all the information they needed. He's actually the one that cares about water transfer.
Yeah,
right. And that would say that's a pattern that we've kind of decided to go and change, because as soon as we wanted to do like dual synchronization, like two-way synchronization, like it opened up Pandora's box of complexity in edge cases. And so that was one of our lessons learned in our journey on that, is now really trying to like remove all our infrastructure, especially now we have more good bandwidth on site, we move all the data to the edge first. And then we have to have this one-way pipe to the cloud. That simplified our operations, our data operations, like tremendously. Yeah. And also works with our philosophy of like, we want the person on site to be the first to know. And so that was one of our lessons learned, I would say, in the past few years when we were trying to pair up and make sure all those applications stayed in sync. One-way database sync is much easier than two-way, and it's not just twice as hard. It's a square rather than a multiplication.
Yeah. Well, I mean, and let's stick on that too, because I think my team had been talking to you all, and then one of our DNC techs left, and she was a big advocate for Coldbore, and just for whatever reason never got legs. But I mean, I'm more concerned on the data analytics side of it. How do I consume the data from Coldbore? Like, are you guys going to generate all this data? And I think it seemed like you guys had two ways for me to get the data. We could wait for it to get to the cloud, and we could access, say, a RESTful API, but then you also had an MQTT service as well, I believe, that we could tie into. So if you're not going to talk about those options. And
Sure. Yeah. So I'm going to talk about a lot of the lessons learned there. So on site, we do MQTT, and we do MQTT WebSockets, right? So we have two ways to do streaming on site. WebSockets, it's more like the common web native approach to streaming, and MQTT because there's so many kind of IoT type devices that have that sort of built in. And then you have the API, right? And on the cloud, we started to do some MQTT as well at some point. We're starting to stay away from it because I guess like you need to have sort of a giant MQTT broker where you have to parse everything through. And it didn't really scale well. So like right now, what we're really looking into is like you say, from the data analyst standpoint, where we decided to go instead is more of providing queuing through some Kafka queues, right? So now you have kind of three ways to get your data, right? You can query it through an API. You can sit on a WebSocket to get in the stream in real time, but you have also the queuing, which is kind of a hybrid of both those things. Because the problem is always like, well, an API, if I give access and everyone wants to do second per second data on my API, they're going to just crush my AWS, right? Yeah. Which obviously is a problem. Streaming, well, from the client side, is like, well, if my client dies for an hour and I don't realize it, then I have to do API queries, and then like all of a sudden your client becomes super complex because for failure, error recovery, there's so many edge cases that pile on to make sure that you have all your data. So what we went to is two other options that are kind of a hybrid of that. Like first the Kafka queue. So that way, like we drop the data, like we standardize it. So like basically you end up with a bunch of queues that are your standard channels that you want from your frac, right? So for each job, each standard channel, and again, like whatever service companies out there, whatever operator you are, these things are always named the same. So from the operator standpoint, like you don't really care if it's Liberty or Halliburton that's fracking,
Right.
like it's always going to look the same for you, right? So that's another big piece of what we do is we create this abstraction.
As it should.
But then with the queuing,
that's just an industry problem, right? Like I'm gonna
overall,
like so, everybody should try and standardize naming conventions, at least on the services side. I think it's crazy to me that as an industry we don't just have a generic naming convention that most of us agree upon. We don't even have that. Like we don't even care about structure or any of like the file types or any of that shit. Just like a naming convention that is standardized across frac. We don't have that. Like companies do, but as an industry, we don't. And that's crazy to me.
Yeah. And so, going back to the queuing. So you have those standard channel, and then we can queue up to 6 hours worth of data for each channel. And so then the client can kind of go there and consume that as they want. And that's been that's something that we're rolling out right now to some customer that's been very good in simplifying the workflows. And then you also have we work with Snowflake, so or whoever other type of Snowflake like thing to be able to do those shared rows.
Okay, so y'all do the Snowflake share now, where you can just like share it across because like three.
You're talking about
3
his
clicks.
Language.
Yeah, no, that's.
He loves a Parquet file.
Not even that. I mean, we don't need that. I mean, literally, like if they have Snowflake, we have Snowflake. You give them your account ID, whatever, and bam, their data shows up as a database in my warehouse without ever having to do any ETL.
You can literally join to our database essentially, right? Because you see them just like there were rows in yours.
Once it's enabled, like it shows. I mean, we actually have it with Liberty, and like it just shows up across the wire, and now it's part of your database.
We should just get rid of APIs, and that's all.
It's moving there, and I mean, it'll never go away, but it's moving there. Like, I mean, that's the idea, Salesforce right? And AWS and Salesforce and Snowflake have it, where it automatically syncs. It's just there.
Because then we all spent our time we're all in the same AWS data center here, and then we keep going over the internet, right? And then the Snowflake guys are just like, hey, what about we just stay in the data center over that big fiber optic as big as this, right? And just do a share of our SQL query, our SQL table. So that's pretty. That's super fast.
Yeah, now that storage is decoupled from the compute now, then it's just you're just sharing their file structure across, and then it just works.
Yeah. Oh, that's God.
Yeah, it's a pricier model. So we'll see. I'm excited to see a bit of competition in that space. Snowflake is obviously the big one. The other one is Databricks, which is also a big one. We've been kind of interacting with both those platforms. But there's a lot of, and we've worked with customers that have started to look into, because there's some open source project that are starting to crop up on kind of the same patterns that will make that a little more economical, I think, for everybody. So that's going in the right direction. And
ClickHouse.
Yeah, we see, how do they call it? Name escapes me. There's one of those open source project that's very popular, something share.
Okay.
Yeah, I'd have to look it up.
Yeah, I mean, I was saying DuckDB or ClickHouse. I mean, just as far as those are right, those columnar, engines that compete, on the same scale of a, Snowflake or whatever. But and again, they're, but I mean, even that. I mean, I don't know. I guess I'm a DuckDB bro who hasn't even really used it that much. But curious. I'm always trying to see if people have even messed with it, because I mean, I think that's one of the things that's so cool about that is it's SQLite for analytics. Like, you can run DuckDB in the browser, you can run it on the edge, you can run it in your data center, you can run it, just about anywhere. So it's pretty cool, but I don't know if y'all are using anything like that at all or messing with it.
Not really, not right now. One of the main challenges on the database side for us has always been the time series stuff.
Yeah.
Right. The way that we handle time series data, because it can get really crazy as soon as you have like engineers that are starting to pound at your web application and look at charts over like, oh, I want to see the frac chart over like the last 15 days.
Yeah.
Right. That's like 10 million data points that I want to throw at the browser. Right. So
yeah, Bobby and I have had many, because we were doing like mostly DFIT or frac analysis, right? So it's all 1 second data, but it's normally during, a DFIT might be a month before the frac or whatever, but even during the frac, right? Like they're looking for frac hits during the entire frac job. So they want to see 30 stages with 30 potential frac hits across it over a 2-week period. And we've had many conversations, Bobby and I, about like with potential customers or engineers of like, you physically can't fit all of those data points in the pixels of this screen. So we cannot show you every single data point. I know you want to see every single that you think you want to, but we had some like smart little algorithms and stuff that were kind of windowed as you zoomed in and out that would kind of expand or contrast. And I think that's what most people end up
But
doing.
even that to hit, those still have to interact with the database, and you need to have a database that's able to handle that. So, as much as you're willing to say, I'm curious if, what technology you've landed on, or did you kind of just home grow the way you're ingesting stuff into a relational database? Because I know, Postgres has timescale, or there's influx, and there's all these different kind of time series databases. So curious what the journey has looked like there.
Yeah, we use timescale. I've always been not a big. I've worked with SQL for so long. Like I kind of like we ended up there because it's something you're like super comfortable.
It always
with.
does.
Yeah, it does always works, right? So times and it's been very successful. Like you're saying, like it's kind of like you have your built-in ways to create samples of certain buckets of time. And then you can adjust the query from the web application and stuff like that, and then really able to get that level of performance that, from a UI UX standpoint, you want to be able to provide the customer. I would say there's been a bit of learning in terms of the way we're sampling things. I'm more from like the finance side when it comes to like, I'm kind of a finance bro. So like the first time I looked at a frac chart, I was like, how the hell does people how do you look at this and so there's been a bit of learning on at least for me and a lot of the other engineers that I'm working with that are not from the industry as to like what a frac engineer expects to see, right and how we sample that data so that it looks right when we do some downsampling of data because that was one of the issues that we had earlier on was that the way we were downsampling was not like they were like, if I zoom in, it makes sense. But if I zoom out, I'm looking at this chart and it looks wrong, right?
We've felt those.
We know exactly what you're talking about.
It was funny too. I don't know, like even you guys arrived on timescale and John and I went through things. There were a lot of architectural decisions that I wanted to be able to do, but what I would tell our CEOs, like, I want to do these things, but like what you realize, and you want us to compete with Well Data Labs or Coldbore or Corva, like, it's like, it's me versus like 20 Ukrainians, like, and but I hear some of these things like, man, we were on the right track. We just didn't have necessarily the resources, whether it was time, people, or I guess it's or
even experience too.
Yeah,
right?
Or the experience. I wasn't at the point then. I'd gone through a coding boot camp.
Right. No, that's,
that was some learning for me too. Like even the way that those time series database like influx and timescales have evolved over the past like just 3 to 5 years is massive. It's just massive, and I'm like I think that I'm starting to understand that's why only the big ones were kind of doing those type of like high volume of data applications, because before that we really don't have any great tools to be able like as a small shop to be able to do that by ourselves, which surprised me that even like that in the late 2010s, early 2020s, we're still kind of at that phase in terms of the stack. But it is true. It's only, I would say, in the last 3 years that we have really seen some. They were open source and enterprise level, so there's a freemium type of licensing. But that's really kind of like in the last 5 years, we see things that we can use at scale and at enterprise level, and not have to deploy like a team of 25 engineers to tweak and manage it inside your organization.
especially like timescale. I mean, timescale was the right call then, but like at the same time, it was before there was really any managed timescale services. So then like it was,
right.
the contractors were using were standing up Postgres, with timescale on a VM on AWS, which A is expensive, and B, like they didn't even really know how to set it up properly and optimize, so, which is one of those like when you don't have the time or people or resources to really dive into it,
I mean, timescale, they've just released their own managed service. Like they were outsourcing their managed service to another company that was hosting their open source
Ivan,
thing.
And I know was doing it.
Yeah, it was Ivan out of Finland, right? They were doing that for them. Now they've just moved their stuff out back to North America, but that gives you an idea of like how still pretty young, that all is.
Interestingly enough, I think you could spin up a timescale Postgres on Azure before you could do it on AWS. Like, they've got that as the managed service. But
I want to know, just as much as you're willing to kind of talk about or can talk about, kind of what y'all's stack looks like specifically around, are you using like containers, Kubernetes? And then I also heard you mention Kafka. Like, I think Kafka is a really interesting tool that some people know about in the industry, but a lot still don't. And then you've also got, Confluent, so you've got the managed version of it and stuff like that. So I'm very curious about kind of, what y'all's architecture looks like and what, things y'all have been able to do to help, like just containers, right? Like when I was selling Edge, the amount of people that are still running VMs for so many things is just, and it's not just oil and gas, right? It's like pretty much every major industry has a lot of very big VM players that have always been built on VMs. So they are still built on VMs. And so like just things like that, right? Like that, I'm very curious to kind of to hear. Like, and again, if you can't share or don't want to or whatever, that's fine too.
No, I don't think there's no big secrets there. I mean, we've always been running Docker stack for both on the edge and cloud. Like we have this microservice type. Yeah, we have that microservice architecture. Stayed away from Kubernetes. I mean, the reason, like, I was working with one of our contractors. He's a guy from he's a guy that was working at YouTube before, a guy from the Valley, and he worked with me when I started. He was one of our contractors, and he was kind of adjacent to the team that was working Kubernetes, and he was like, dude, like the amount of people that actually need to use Kubernetes is really fucking small. Yeah.
No, I wholeheartedly agree. Like that was, in my opinion, one of the main kind of negatives about, I thought it was a positive going in because didn't know better, but about the Hive cell setup was that, the Kubernetes offers that resiliency and high availability that at the edge we think we would ultimately want, but then of course no one actually wants to pay for it until they have that issue where, oh, well, we were in the middle of a frac stage and all of our equipment shit the bed and now we don't have any data. And it's like, well, is it really worth that like mitigation, or do we just have a backup sitting out there that we can plug in and keep going, right? Especially just like the expertise around Kubernetes is still so small. Like,
and that's the thing about engineers. Like we work with engineers and software, at least that I can talk to that because that's my world. But like, it's like, they're attracted to complexity like moth to a flame, right? And so like everyone wants to do Kubernetes because like that's what the cool kids do type deal. Like we've been running our Docker Compose stack for forever, and we know everything that you used to know about it, and we never had any issue. Like it's not even on the radar of the things that we're worried about, honestly. And so we've been running that. We do some hosted service, like we leverage some hosted service on the cloud. We're me and Cooper Gradishar is our director of technology. He's like we work together for a GD together and all that, and we're kind of Linux geek, right? So we're a bit more like old school when it comes to like our run our stack in the cloud because we know how it works, right? We use less, let's say, managed service than maybe we should, but it's more like we know how they work, we know what we need,
you can go fix kind of.
Well, that's the thing, right? It's like when there's too much magic AWS shit, I'm like, well, like if it doesn't work, we're like, I don't know where to start. Like, I don't know what AWS wrapped this in, right?
No, I mean,
if I run an EC2 instance and I have my SSH tunnel to my logs, I can probably do a lot of things. So that's a bit more of our philosophy because of our background. Like, I understand why it's there, but we're more kind of like the technical guys that want a little more level of control. So we do some managed stuff when it makes sense, but not kind of like as a default. What we've been very different about is that we've built a lot of our software on new technology. So, for example, everything that we run on site when it comes to embedded is all pretty much all Rust. Because, again, it's back to the story of Cooper and I working for the defense industry in C++. And you're like, hey, we're not doing this C++ thing again.
No. Well, you get the benefits of C++, but with more type safety and everything, right, on Rust?
Exactly. The type, and mainly for the memory safety.
Well, not type safety, memory safe, sorry.
Yeah, the memory safety is such a blessing. Like, and everyone that says like, well, it compiles more slowly. Like, you really need to revisit your assumption about what's important. Like, if it takes 5 times the amount of compile time up front, and I'm going to save like 16 million hours of debugging a 12 thread process that crashes every 2 months, like, yeah. Like, I'm going to pay that price up front anytime, right? So that's one decision that we've made. And it's been great because first it simplified some of these things and also attracted talent, right? Like we had guys that, and we had people that wanted to work on Rust in production. Right. Like a lot of people were doing this. And that was back when we started in 2020. And now, like, looking back, I think that was a great decision because you look at 2024 now and, Rust is part of the Linux kernel. We see Microsoft starting to migrate some of their C++ to Rust as well in the Windows operating system. So it's great to see because, like, it sounds like this is not going away anytime
it's always
soon.
When it's the language, of choice for all like the blockchain.
Yeah, a lot of the crypto stuff is in Rust.
It's fast.
And everything above, like on the cloud side, we've been having a lot of emphasis on using Elixir and OTP. So for those that are not aware, like that's all based on Erlang. Erlang was built by Ericsson for telecom, right? And you can draw a lot of parallel to what Coldbore does at the end of the day. Like, we're moving a lot of data in all sorts of ways really fast. And functional programming is a pattern that, we really kind of embraced when it comes to how we do our development, how we think about our pipeline, our software, what goes where in our architecture. And so that's been kind of like our ways to think about the software, like the language and the framework really fits well with that. And everything on the kind of the website has been a React, classic React JavaScript type stuff.
Are y'all using Kafka, or are you using like Confluent? Or
yeah, we're using Kafka for our queuing, but outbound. So we've developed our own pipes with Elixir and the OTP framework for everything that is moving data from edge to cloud and stuff like that. Yeah. Kafka is more like a way to, because we don't, like, there's a lot of Kafka client, right? So it's easy for a customer to be able to just spin up a Kafka client and read from a queue rather than, have to write a client that uses our special sauce.
So it's not critical to your application. It's more of a way to serve data to others.
Yeah, it's a distribution.
Exactly, like a neat way to distribute the data in a queue to the end user.
Yeah, nice. No, that makes. I mean, that's what they really push Kafka with, right? It's data in motion, and
there's another one. I was on Kafka testing it out early. I was using Confluent to connect to our MySQL, and it was going to go somewhere else, and then again bringing enough contracters, and they overrode that. But no, I mean Kafka's.
That was in like what
2017, because it was Kafka Connected come out, so I was like, I can just write a little configuration file, connect to MySQL. I just had to turn on the bin log, and then just all the data was flowing out of our time series stuff, and I could send it anywhere. And then, but I was just a little wet behind the ears, and didn't really know what I was doing yet. So but there's a lot of things that's like, oh, that's probably the right technology.
Yeah.
Yeah. I mean, those things, like, I mean, these problems have already been solved, right?
Yeah.
So it's like, let's,
it's more about applying the technologies and creating
stuff,
something new.
Yeah, for our stuff, like, we've been leveraging, like, when I say Elixir, like, it's just that it's more of the framework also that we adopted. It's not like those that data movement and pipelines and queues, like all those things already built in the language. And so like you just go with that, and you don't take the risk of having a guy reinvent the queue and go through the same hoops that the guy in 1952 had to go through.
Exactly.
Right. Again.
Even you brought up we brought up MQTT earlier, and seemingly it didn't necessarily work exactly how you guys want it to work. But I think it was Colin was telling me, like, I think MQTT was actually born out of like Phillips 66 or ConocoPhillips or one of those companies. Apparently, there were a couple of guys there who developed the MQTT protocol, which I think a lot of people don't realize it was born out of oil and gas.
I didn't know that, actually.
Yeah, I didn't. It was like probably a month or two ago. He told me. So
no, I would have easily called that was a Valley invention.
But again, but the Valley doesn't have to solve that. You know, they're not messing with the edges nearly. I mean, I guess phones and stuff potentially, but like, it's born motherhoods or necessities of the motherhood of invention. So
no, that was what.
Yeah, that's so true. Stuff, right? The Valley, like when you hear the guy in the Valley talk about edge, talk about modern computing and stuff like that, it's really hard to relate to what we do here a lot of times, right? Yep. Like we're in the B2B also, right? So a lot of the stuff is built certainly more into B2C type. Even if you think about product development, right? Yeah. Most of our, you hire a bunch of product manager, and they kind of have this B2C mindset of like, we're gonna try this on the customer. We're gonna A/B test this. Like, you're not doing A/B tests between ConocoPhillips and ExxonMobil. I'm sorry, right?
Yeah.
So like that's a very different beast, like just from that angle. And also like oil and gas, I think in terms of like adoption of software, adoption of technology, like I think, it's a laggard as an industry or like in general. And so it's always kind of interesting to have to interact and bring new people in our company and to have to interact with a client, because like,
blows their minds.
It's not at all what you've seen before. Okay.
Yeah.
They're a publicly traded $1 billion company, and they're still using MySQL.
Yeah.
Or whatever. Yeah. Oh, that's
yeah. Well, or like, Modbus, like make it that, right?
Modbus,
it's like, Modbus, man.
Yeah. I love pulling things.
Bobby spent so much time with all the interface
different protocols Modbus serial. I mean, all the TCP, good old,
Yep. No. Well, shit, man. That was
it goes pretty
quick hour. We're gonna need you back on at some point. We're gonna try and do in the future some
roundtable,
roundtable topic specific episode, like AI.
If we get him in there with
Federico, that'd be a cool one. That'd be a cool one to do. Is if we talk a bit, like if you want to do a bit of a session about like next 5 years, like what this looks like, what it needs to look like, what success looks like for how we see the industry going and where we fit, and that's something that I've actually done. Like I was on a panel on ISP out in the Marcellus just in the fall. There was a lot of great discussion there around that, and so I think having like you're saying, instead of roundtable type stuff, I think would be great.
Yeah. No, man. Well, we at the end of each episode, we do a little speed round where we kind of just pepper you with random short questions and just give your quick and short answer, and then we'll wrap things up.
All right. So who's your favorite social media follow?
Wow, that's a good one.
It doesn't have to be like an influencer. It can be like a tech guy or just a interesting person.
I would say probably I'm really enjoying following Elon around on Twitter.
That's 2 for 2 today.
Mm-hmm. No, that's always, I mean, he's just fun to watch because all the stuff that's going on. But what is your favorite cloud? Preferred, if you had to pick one.
If I had to pick one, Azure.
Okay, interesting. Because it could sound like y'all do a good bit on AWS too, but
we do both. Yeah, we do both.
Gotcha.
That's how most people should be doing it.
Yeah. You can't lock yourself in. What's your favorite place to go on vacation?
Florida.
Okay. I mean, honestly, like since I went there a handful of times, every time I go to Florida, I have a good time.
Oh, yeah. People shit all over Florida, but Florida's a blast.
Yeah.
It's so nice to go sit on the beach. And
it's a change from here, and especially today.
Yeah.
I was going to say, I can't imagine having, I literally can't comprehend how cold it is there because I've never been that cold in my life.
Yeah.
I've gotten 0 Fahrenheit surface temperatures with 20-mile-an-hour winds, but that's not, it's still not even comprehensible. What is your favorite language or
coding language, or
either language or like library that you've kind of come across that might be interesting or relevant?
Yeah, it'd be Elixir / Erlang for me.
Nice. One more.
Yeah. What's your favorite managed service?
Oh, that's a good one.
What do you mean by managed service?
I mean like a
third party,
like a third. I mean like maybe Auth0 or those kind of things. Or
it's definitely not Auth0.
Well, John doesn't like Auth0, but I mean I don't just like
guys.
Or
I mean for me like it's GitHub, man. That's like so much of our workflows, and it makes so much sense from a developer's mind.
Right.
Like I do everything now in GitHub. Like I do accounting, I do like everything in that workflow. So that's kind of one of the things that's open in my face, like
nice
24/7 almost.
No, for sure. I mean, I started diving into the GitHub Actions over the winter break, and pretty awesome what you can do with that.
Exactly. Yeah. And yeah, like now my brain just keeps going back to like, I'll just make it a GitHub workflow.
Yeah.
Done.
It's smart. I mean, you gotta do it where it's most accessible and easiest to do. Well, where can people find you? How do they get in touch with you or Coldbore?
You just find me is on LinkedIn. That's probably like where I do most interaction on social media. I have an X account too, but kind of sparsely there. And yeah, coldboretechnology.com for to get a sense of everything that we do. We'll be at HFTC around, what is it, 3 weeks from now?
Yeah, it's normally end of January, early February.
End of January. So we'll be there. So hope to see a lot of people from the industry there in Houston.
Yeah, perfect. That's always a great show. Everybody, if you like this episode and like this stuff, check out this episode. See what else we've got. Alex, thank you so much for jumping on with us. We really appreciate it. Stay warm.
It was fun, guys. Cheers again.
Awesome. Thank you.